Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 14, Parabolic Reflector Dish. You reached the place where all of the mirrors were pointing, a massive parabolic reflector dish attached to the side of another large mountain. The dish is made up of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in a slightly wrong direction. If the dish is meant to be focused light, all it's doing right now is sending it in a vague direction. The system must be that what provides the energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes, pulleys, and a large metal platform below the dish. The platform is covered in large rocks of various shapes. Depending on their position, the weight of the rocks deforms the platform and shape of a platform controls which a rope move and ultimately focus the dish. In short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side and lets you tilt it in one of 4 directions. Rounded rocks will roll and with the platform when it's tilted, while the cube-shaped rocks will stay in place. You note the positions of all the empty spaces and rocks at your puzzle input, for example, and start tilting the lever of the rocks will slide north as far as they go. As you notice, the support beams along the north side of the platform are damaged. To ensure that the platform doesn't collapse, you should calculate the total load on the north support beams. The amount of load caused by the single rock is equal to the number of rows from the rock to the south edge of the platform, including the rock it is on. The cube-shaped rocks don't contribute to load, so the amount of load caused by the rock in each row is as follows. And the total is. So if we switch over here, we can do this in 2 different steps. We can either read this in and tilt it so we get the right output, or we could do the same thing but try to handle it with... Now, let's do a tilting motion here. We pretty much need a list of strings. Like that. Could pull this down a bit. Move that one. Lines. New array list. And then we do lines. Why is list so hard to import? Add line. So now we want to do a tilt function. Tilt north lines, and then we want to do calculate lines. So those 2 functions we need to fix. So let's go up here and create a calculate as well. So this will return 0 for now. The tilt function is pretty much for int y equals to 0, y less than lines size, y plus plus, and then we want to do the same for the length of the lines, the x position. Get lines get y, substring x plus 1. So now we have the character. And if this equals a big O, we want to do something with it. And in the tilt north, we pretty much want to check the positions north of this character. So for y, y minus 1, this should be bigger than 0. So we will take this again. And here we want to just get another value. And this should be I. If V equals to a hash mark or equals an O, then we need to stop. So here we need to break. Can do more there. And then we want to put this into I plus 1. So lines get I plus 1. And we also want this we want to do a substring of 0 to x. And then we want to add the dot there, and then we want to add the rest. Substring x plus 1, and then lines set y s. So this part here we pretty much want to make into a function. Private static void set char at lines x y. Like that. We want to have this. We want int and int. So char at lines y x string value as well. What we actually want to set. Like that. So here we want to set chart value. And then down here we want to set an O at I plus 1. And the X position, not to 0. O, there we go. And we break out this loop. So that should move it. There we go. So if we take the current value here, if we go here, then we should have these lines. If we tilt them north, so if we don't break, we will put it at the top. If I equals to 0 and it's empty, then we put it right there. So now I only need to go through and count them. And we start from 0. So long val is equal to 0. We will return val. Here we do val plus equals to 10 minus y. What do we get? 136. That is correct. I believe. Yes. And if we go up here and switch to the different run sum value, 136, and this value was 105,208. Put that in. Let's see. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So that was part 1. So let's go into part 2 then. This video series is sponsored, so for all your hosting needs, go to DigitalOcean. If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description. The parabolic reflector dish deforms, but not in a way that focuses the beam. To do that, you need to move the rocks to the edges of the platform. Unfortunately, a button on the side of the control panel labeled Spin Cycle attempts to do that. Each cycle tilts the platform 4 times, so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before the platform tilts the next direction. After one cycle, the platform will have finished rolling the rounded rocks, in those 4 directions order. What happens in the example above after each of the few cycles? In this process should work to leave it running long enough. You're still worried about the north support beams. To make sure that they survive for a while, you will need to calculate the total load on the north support beams after 1 billion cycles. In the above example, after 1 billion cycles, the total load to the north is 64. So I guess that we need to have something that flips this. And we are back, and I haven't been able to analyze the results for day 14 for a while. I have had a lot of things to do, so I just haven't been coming around to it. But today I had some extra time, so I thought, okay, let's look at what I actually got on day 14. So what I've created here is something that is pretty weird. I have a working data dir, which I call day 14. And if we look at this data dir, there is a bunch of data files in that. And it contains the full map after you have actually moved it around a bunch. And what I do up here is pretty much read in the largest value, so the furthest I have come in this run. And then I either start from the first data file, work file, or I start from the latest iteration, latest save file, for instance. So I read that in, and then I have these movable and immovable that we looked at earlier. And I go in and run through all the lines in this list. I split it up and I create all the movable places, which is hash marks, and all the movable ones I put into both immovable and movable. And then I have these large thing here where I go from I to a billion. And for each million, I actually write this down, this data file that this is how far I've come. So I write the map down there and I can start over. And then I need to sort this in order for it to be able to move north. So I actually get them in the right order when I want to go north. So I sort it by the Y position. When I want to go west, I sort it by the X position. When I want to go south, I need to sort it with the Y position, but reversed. And the same goes for east. So I do a full flip, and then it's next operation. And then if I ever got through all of this, I would print out the value of all the movables. So I can actually get the result down here. But I never got there. I have run it for a bunch of million iterations. So the last file here is 65 million iterations. But I ran it through this, and today I created this file called counter. And the first part I did was this thing that I commented out here. I fetched all the data values, I sorted them up, and then I pretty much printed them on screen. So this was an attempt to do it not manually, actually trying to figure out an initial list and then go through and calculate a window, small window, and then figure out if I could find a window of million files that are similar. But that didn't work out for me. But what the big thing here was to take the file in and type the value out. So the rest of the things here we can pretty much ignore. If we see at the result of what I typed out, it went like this. And after looking at this, if you see here, you see that it actually repeats. And it repeats very regularly. After 21 million tries, it repeats. So I took this list and then created a manual list of what point it actually turns out. So this value ends up in 1, 22 million, 43 million, and 64 million, and so on. So I created this long list, and now I could go back again and manually run the first little loop up here where I started at 1,000 and then decreased with 21, and the last value I get there is 13. So I know that in the list of 13 is my value. So that should be my value for this. Let's hope that I've done it. Yes! You get a gold star! I get a gold star! Everybody gets a gold star! So that was day 14. We needed to figure out the actual pattern that was going on, so we didn't have to do it for 1 billion tries. We only had to actually do it for, let's say, 13 or 20 billion, and then perhaps we could see 21 billion and then 21 million, and then we could see that it repeats and try to figure out which value were the correct one. But this was today's video. I hope that you liked this video. Give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. I guess you solved this in a totally different way. Please leave a comment in the comment section down below how you solved it. And I really hope to see you in the next video.